In this video, we're going to work on a near real-time, fully Airflow native, end-to-end data engineering project. We're going to source the real data from a real API, no fake data or no mocking services. We will be extracting the data, cleaning it, transforming it, and loading it, everything using Apache Airflow from beginning to the end. This one is also beginner friendly, so everyone can understand it and work on it. On top of that, this is a portfolio ready project, so you can add to your profile to showcase your Airflow knowledge. With that being said, let's begin. In this video, we're going to work on the project named Flight Operations Analytics, which goes like pulling the data out of a data source, which will be an API, and transforming the data into business ready one by cleaning it, then creating a dashboard to our clients. In our analogy now, we're going to take our clients as aviation analytics and operations department, whose job is to monitor the flight patterns and analyze them. So this dashboard helps them make better decision making. And my main motto to do this project is to create a project which is mostly Airflow native, which means the main tool we're going to use in this project will be Airflow, and we'll use Python to transform the data. And we also will or can use Snowflake in this one, but that is complementary, that is not mandatory here. We can just use any tool, but the whole project is mostly Airflow native. Because I just want to follow up with my last masterclass, which is Airflow masterclass. So this project is a very good suited for the beginners who are just beginning the Airflow. So this project is a very better option to learn more about it. So we're going to use Airflow as our main tool here. Okay, before getting started, before we work on the project, we have to know about the blueprint. We have to know about the data pipeline we're going to work on. Our data pipeline starts with the data source, which will be an API. For the API, I chosen OpenSky.org as our API, which provides real flight data. Yes, we're not going to use Faker or any fake data here. We're going to use the real flight data by OpenSky.org API. And that data will be stored in bronze layer first, which is our raw data layer, and then cleaned and stored in silver layer, and then it goes through some aggregations, and we make the data business ready, and then store that in gold layer. Till bronze and silver, we'll just store the data in JSON files, and then in gold we store that in CSV. And the reason for that is it is so easy to connect and work with a CSV formatted data. Because, like I said, Snowflake is not mandatory. So if you don't want to use Snowflake in this project, you can just save the file in CSV format. I will show you how to save the file in CSV format, and how to save the file as a table in Snowflake. I will show you both the methods. If you don't want to work with Snowflake, you can just save the file as CSV and then connect Power BI or any visualization tool like Tableau directly to .csv file and work on the data. You can create a dashboard out of it. But what I'm going to do in this video is I'm going to create the CSV file, and also I'm going to load the data into a table in Snowflake and then create a dashboard inside Snowflake, which will be a lot easier and more efficient and makes the data live. So everything here in this pipeline, the whole pipeline will be real time. It will be updated for every 30 minutes or whatever you specify. In this video, I'm going to define it as 30 minutes. So it is near real time, not real time, but near real time. That's it with the architecture. Let's begin with the first step. The prerequisites for this project is to install Airflow in our PC. There are a lot of ways to install Airflow. We can install directly onto our PC, but that is kind of hard to uninstall it back. But the best way is to create a container in Docker desktop. So I'm going to install Docker on my PC and then create a container for Airflow. For that, you just need to install Docker desktop. I'm going to provide the link for you in the description to install this. You can just go to their site. It is also available in Microsoft Store, so you can just download it, install it with the default settings. You don't need to change anything. You can just skip the sign up process too. You don't have to sign up with an account. You can just skip it. So after installation, you open Docker desktop. This will be your landing page. Right now there are no containers created, so this is the landing page. Next, after installing Docker desktop, you have to create the tree, create the repository skeleton first. So this is a skeleton we're going to create now. So this will be the root folder, root repository, and these are the subfolders and these are the files. So we have to create them first. So let's do that. You can do that using UI, or you can just use it using CLI. CLI will be a best thing to go here, so because that is a lot easier. So I'm going to use CLI. So in case, you know what, just because this project is for the beginners, I'm not going to use CLI here. I'm going to create the folders manually using the UI, so you don't get, you don't feel it hard to follow. Okay, so you go to your local disk, users, and your username, and here we're going to create the root folder, name it Flight OPS Airflow. I just used OPS, which stands for operations, so I just used it a short form for that. And then here, our next folder will be DAGs. Basically, you don't have to create DAGs, because when I compose the Airflow, when I create the Airflow container, Airflow, the Docker will automatically create those folders for us. So I'm not going to create the DAGs. I have to create scripts, I have to create SQL, I have to create data, and this file, docker compose.yml. I'm going to give you the link. I'm going to give you the link for the GitHub repository, and you can find the docker compose.yml in that repository. So you can just download the file. And also the requirements. Requirements are nothing but what to install on our PC in order to run those codes. Okay, let's create those folders here. The first one will be scripts. Scripts and SQL. And then data. You don't have to create SQL folder if you're not going to use database, which in our case here, I'm going to use Snowflake. So that is not mandatory to create. If you're going with the normal one where you just use the CSV to connect Power BI, you don't have to create the SQL folder. We use that folder to save the create tables query, which is used to create a table in Snowflake. Then we have data, and inside data we're going to create 3 more folders. One for bronze layer, one for silver, and the other one, the last one, is for gold. That is it. And we need requirements.txt here. I'm going to create that later. Okay, now we have all the folders ready. I'm going to pin it to quick access. So I don't have to, go from the root of the folder. Now, what I'm also going to use in this video is VS Code. This is not mandatory, this is optional. You can do this in any other code editor, but I'm going to use Visual Studio now to write the codes, just to write it. You don't need to have this installed to run it. You just need it to write it. It makes it a lot easier with the UI, so I'm going to use that. Visual Studio Code. Basically, when you open the VS Code editor for the first time, you don't see the Explorer here right away. But how you can open it is, you click on File. Okay, you click on File on the top left, and click on Open Folder. And here, you pick the folder you want to see in this UI, which in our case will be Flight Apache Airflow. I'm going to select that, click Select Folder, and then it will appear here, like that. Okay, we have VS Code ready. Now, under the root folder, I have to create a file named docker compose.yml. And I already have that file created. That's just a Docker code, the YML code to create the Docker containers. So I already have it ready. For you guys, you can just download it from GitHub. You don't have to do all this. Okay, here I'm just going to create the mandatory containers that has to be initiated in order to run Airflow. If you watched our last video, which is our Airflow masterclass, by now you already know there are types of executors. And for this video, I'm going to use local executor. See that actually. You don't see that here, but we are going to use local executor. And the minimum requirements to run Airflow with local executor are, like I said, scheduler and a metadata database. And here we're going to create 3 containers. 2 are mandatory and 1 is complementary, that is optional. And the mandatory containers include Postgres. We're going to create the Postgres container for Postgres database, which will be our metadata database. That is a required container. That is a required component to run Airflow, right? So we have that. And we're going to create actually 4 of them, not 3. I'm going to talk about the mandatory containers first. The first mandatory is Postgres, which we just talked about, and then the next mandatory container is Airflow scheduler, which is responsible to run the task, where to run it, and when to run it. And then web server is not mandatory, but it is optional. This is basically the UI of Airflow, right? So we're also going to create web server, and when we want to run Airflow, we have to first initialize it. You remember when I talked about initialize in the masterclass? So we have to initialize the Airflow first, which basically creates the database and connects it to the server to scheduler and the components. So we have to run it first. So this container basically runs these commands: Airflow DB init, Airflow DB migrate, Airflow user create, and username. So it gives all of that. So these are the containers that we are going to create, the components basically. Two are mandatory and the other no. Two are mandatory and one for the initialization. So that is also mandatory. And the web server is not mandatory, but we want it for the UI. And for this one, I'm going to use the version 2.9.3 because that I'm much comfortable with that version to work on. So I'm going to use Airflow 2.9.3, but the latest one is 3.1.5, I guess. And that's it. We're not going to create any containers for workers or any containers for tag processor because they're not mandatory. And this is local executor method, so we're not going to use workers. And the reason that we're not going to use tag processor is because it is not mandatory, and the tasks that we are going to do here are not that big because this is just a beginner level project, so we're not going to use that as well. Just the scheduler does all the tasks. So if you don't create DAG processor, the role of DAG processor is to process the DAG files, to pass them. So when we don't create a container for DAG processor, the component, that load will also be handled by scheduler itself. I mean, that makes the scheduler a little bit slower, but for the workload that we are going to give in this project, that doesn't matter. So we're just going to use scheduler for all the tasks. Now, if you take a close look, to create a Postgres, we need the credentials to be entered. But here, to make it professional, we're not going to hard code the credentials right here. But if you want to just, just for the practice, you can just type in the username and password right here for the database. It doesn't matter. But if you want to make it look professional and feel professional, you don't just hard code those credentials here. What we actually do is we create a .env file, an environment file outside this Docker Compose file, and there we define those credentials, which will be pulled using this symbol, this this format. So we pull the username and everything, username and password and the database name as well from that .env. And also we do the same for what else? I think it's here. Yeah. Wait. Yeah, here, right here. So we do the same to create a password, to create an account, basically, with Airflow as well. So we're going to, replace all this with the placeholders instead of just hard coding the username and password right here in the code. That is not a best practice because we actually use CI/CD and we upload these codes onto GitHub for the version control and stuff. So when you upload these codes to GitHub, it is not a good practice to have all your credentials inside the file. And moreover, GitHub won't allow to upload a file with credentials in it. It just says the warning on the UI as well. So you don't have to do you should not do that. So yes. So this includes username, first name, last name, and what else? Role, email, password, everything. Everything will be pulled from the .env file that we're going to create now. So, but for now, they are just replaced with the placeholders here. Okay, now let's create the .env file that I'm talking about. Right here in the root folder, I'm going to create another file which is named .env. And here, first for the we're going to put in the Postgres credentials. Which includes Postgres user, equals username. I use J. And then we have Postgres password. I use flights as password. And the database name will be flights DB. Perfect. Now the credentials for Airflow. Airflow credentials. And the first one, Airflow admin user. No, yeah. Airflow admin user, which will be our username. I'm going to use the same username here, J. And then we have first name, copy paste it here. Use J as my first name too, that's fine. And the last name, okay, that should do. Role. A role is already assigned, so I don't have to do that. So role is already given directly. And then we have Airflow admin email. I'm going to give some random email, that's fine. And then we have Airflow admin password. I'll use the same password so we don't get confused. So I'm going to use flights as my password for Airflow 2. Now save this file. Make sure you save the Docker file too, and place in this location, the root of the folder. They should be saved in the root of the folder. And lastly, we create a new file. We create another file, requirements.txt, a text file which includes all the tools that we have to install. For now, we need to install .env, python.env. To actually let Python read .env files, we need to install this. And again, this is not mandatory, this is optional. If you want to make it, look professional and want to create a .env file separately, then you need to install it, or else you don't have to. So we need to install this in order to let Python read the .env files, the environment files. Now we have everything ready to initialize the containers to run Airflow on our PC. So let's go open Docker desktop. Then first we need to install .env. So open terminal. Sorry, but now we have to deal with the CLI. We don't have UI for this. So what we have to run first is, so yeah, for the people who are using CLI for the first time, this thing right here says the location where we're running the program. Right now we're at local disk C, users, and your username. But where we have to run this is inside flights ops airflow, because here's where all the files are located. So what we have to do is we have to run cd. cd stands for change directory. Now we are changing the directory to our new directory that we just created, which is flight operations ops hyphen flight hyphen ops hyphen airflow. Run it. Now we're inside our project's root folder. Here is where we can install or initialize the Docker containers. The first thing we have to run is we have to install the requirements, the python.env. So we run pip install. I have to say -r because we are reading a file here. The flag -r says it to read the file, and the file name requirements.txt. Run it. Well, here it says requirements already satisfied. Python.env is already installed because I already installed it. But if you're installing it for the first time, it takes a few seconds to install, and it says installation completed. You'll see a different dialog here. Okay, now the first step is completed, and our next step is to create the containers. To do that, we run docker compose -d. -d represents detach. If you don't use -d, you can still create the containers, but this terminal will be dedicated to that, will be connected to the container. So it keeps on shows you the, the processes, the logs that are going on. So if you do -d, you're saying create these containers, but detach the terminal from the containers. So we run docker compose up to create the containers. If you want to close the containers, we run docker compose down. Okay, there you go. Now what happens is all the containers will be active at first. After a few seconds, after initializing everything, after creating the database, metadata database, and connecting that database to the scheduler, Airflow initialization, Airflow init should be turned off. That is how you know everything is working fine. After that, after you see Airflow init is turned off, then you can go to web server to check on the UI. And here's how you can do it. Right from here, in the Airflow's web server section, go to the ports. It shows HTTP localhost 8080. Click on it. What happened for me is, before when I clicked on that link, nothing showed up. It says the page not found. How I fixed it is I just stopped the containers, and then created them back again. That's it. You see here. yeah, I just ran Docker Compose down, and then again I ran Docker Compose up. Now it is working. I don't know what was that. I think it was a glitch. Now the port is working. You can see the UI here. Now you have to log in with the credentials that you used when we created the containers. These credentials, by the way, these Airflow credentials, not the Postgres. You have to use the Airflow credentials to log into Airflow UI. Mine is J and Flights. There you go. So this is the UI. If you already watched the last masterclass, you will see the difference here between the UI that I used there and here. I mean, all the options are same, but just the UI is different. This is the 2.9.3. I think this is a different version than that is 3.1.5. So that is the latest UI. This is the old one. I'm comfortable with this UI, so I'm using this one here. And yes, rest of it is everything is same. If you haven't watched the masterclass yet, I strongly recommend you to watch it, because that makes a lot different. That makes you a lot different by watching this one. So that is this project is just a follow-up for that video, just to keep up with the pace. Any DAGs we create and place those DAGs in the DAGs folder, we can see the DAG here after the scheduler passes it, and the DAG doesn't have any syntax errors. Then you can see the DAG here, or else it pops up an error here saying it also shows the error. So you have to fix it before it actually shows the DAG in this DAG section. And when you run that Docker Compose, you will see these folders created by default, because in the Docker Compose.yml file, we initialize these volumes here. So we initialize DAGs, scripts, logs, plugins, data, SQL. So basically, we don't have to create any of these folders. When we run that Docker Compose, it will automatically create, but that's fine. If we create it, that is still fine. Both will work. So we have DAGs now. This is where we have to place our DAG files after we code them. And then we have scripts, and we have logs, where it stores all the logs of the DAG files, and then plugins, and then data, and then SQL. Anything you want Airflow to have access to should be initialized here in the volumes, any storage space, because Airflow cannot have access anything out of this storage space. So it cannot access any other folder other than DAG, scripts, logs, plugins, data, and SQL. Any other folder. Let's say you create a new folder here named TMP, temporary. Airflow cannot access it. Airflow cannot read from it or write to it. So you have to initialize the volumes here first. So Airflow have the control with those volumes now. Now let's head back to the architecture and see our first step. Our first step is to pull the data out of the data source, which is our API, which is from an API, and then store it in the bronze layer as raw data, JSON files. Okay. For that, we have to create a DAG, which, if you don't know, DAG stands for Direct Acyclic Graph, which includes a list of tasks to work on with, and we are going to have 3 tasks in that DAG. Now, 4 tasks, by the way. 3 are mandatory, and 4th one will be ingesting the final gold business ready data into Snowflake. So that is not mandatory. That is up to you. But the mandatory ones are 3. So we're going to have 3 tasks. But instead of making all the tasks, instead of coding all the tasks in the same DAG file and making it a bigger code, what we're going to do is we're going to split these tasks and code them in separate .py files, and then call these, the main functions from these .py files into the DAG. So the DAG looks shorter, and these tasks will also look shorter. And yeah, that will not feel overwhelming for anyone who want to read the code. So yes, for the first task, we are going to create the task, which is a separate .py file for bronze, and then we are also going to create the pipeline, and then we assign the tasks to that pipeline one after another. Okay, heading to scripts. Scripts is the place where we are going to save all the tasks, and the DAG is the place where we're going to save the final the main DAG file, and we're going to connect these tasks to the DAG. First, create the task. Click on scripts, new file. Let's name it bronze underscore ingest .py. Okay. For this task, to begin with, we're going to import requests, and requests is the module that we use to call any HTTP request, because we have to pull the data out of an API. So we're going to do a HTTP request to get those data from the API. So we need requests for that. We need request module, and we need JSON. Like I said, we're going to store the data as a JSON file. So when we are dealing with the JSON files, we have to import the JSON module in order to make it easier for us. And then we have from datetime import datetime. We're mainly going to use this datetime to assign the datetime, the current date when the file is getting created, to the file name, so we don't get confused when we pick the latest entering data when we run the silver transformation. So we're going to use datetime to get the current time and assign it to the file name. From path lib library import path. So this module is not mandatory, but this makes it this comes with a lot of benefits. This comes with a lot of benefits when you're defining a path. So that's why we are importing path module here. And first, let me talk about the URL that we're going to use. And this URL will be available in the description and also in the GitHub README. But check the video description first. If you don't find it, then you will find it. So you don't have to go to GitHub, by the way. You'll find it in the description. And the link is this one. We're going to pull the data out of this API, and I'm going to show you the data that we're going to pull. This is the data. This is the live data that is getting generated. But if you look at it right away, you don't understand it because it includes a lot of stuff, but they don't have the right headings to, in order to a human to understand it, to comprehend it. So they also have formatting by which we can understand the data. Wait a second. Okay, here it is. I will also be providing you with this link as well, which includes the format the data is arranged in the order. So it has the index number and the headings that it has, and the description of that particular column too. So it has a lot of columns, almost 18 columns, which includes ICAO A0 to 24, which is unique IC A0 24-bit address of the transponder in hex string representation. So it is like a unique identifier of each record, which will be this one, this first one. So that is the unique identifier. And then they have call sign, origin country, so which says the origin of the flight, country name inferred from ICAO 24-bit address. So we're not going to use all these columns. We're going to pick a few from this, which are actually useful for us for the project. So I'm going to pick this unique identifier, and then origin country, and then what else? Latitude, longitude will also be useful, but I'm going to pick velocity, and then what? And the altitude. I mean, in this project, we're going to pick a few of them, just a few of them to make this project beginner friendly, but I'm going to make another project with this same API, OpenSky API, and that project, I'll make sure it is, industrial grade, and it includes all the, production grade tools in it and make it big. But for now, we're going to use these 4 attributes. That's it. Okay. That's it about the data that we're going to, work on. It has a lot of records, by the way. See that? And everything is real. Nothing is fake. Okay, if you have that. Now we define the function. Name it run bronze ingestion. So if you're wondering, we are passing the arguments, which includes star, asterisk, asterisk, context. Context returns the details of the task run. So it includes a lot of methods, and you can import the task instance from it. There are a few uses of it. I'm going to show you 2 of those uses in this project. So we are passing context as arguments. We're not passing any, variables into this definition. We're passing context, which will change every time the task runs. So that is generated by Airflow, by the way. We are not going to pass anything. That is generated by Airflow. Now, requests dot get of, find the URL here. We're also going to define the timeout as 30 seconds. Now, if we don't get any response from that URL for 30 seconds, that pops an error. So this is to request the URL for the data. We're getting the data from the URL and the timeout is 30 seconds. After that, it pops an error. Response.raise underscore per underscore status. That returns the status. Now data equals response dot JSON of. Now we're converting it into a JSON string. So it is a regular string, but in JSON format, and assigning it the JSON string to a variable named data. So now the data is in the variable data. Now we define timestamp equals datetime of datetime dot UTC now of dot ST or FTIM. Of percentage y percentage m percentage d percentage h percentage m percentage s. With this line, we are defining a variable named timestamp by using datetime module, which we imported earlier right here, where we are using datetime.utc now, which imports, which gets the time, the present time in UTC format, and strf time stands for string format time. So we are defining the format of the time to be imported, which includes year at the beginning, followed by month, followed by day, followed by hours, followed by minutes and seconds. Done with that, and the next step is to path equals path of f strings slash opt slash airflow slash data slash bronze slash flights underscore and the flower bracket here, timestamp dot JSON. We are defining the path here where to save that bronze file. We say this is how we define the path in Airflow, because when we let me show you the Docker compose. When we initialize those volumes here, you see we initialize as slash opt slash airflow slash dax, which means this is how you have to refer to that path. And that's what I'm doing here. I'm referring using opt airflow slash data. Now we are here, and then slash bronze, and this is the file name. This is the actual file name, and inside, so the file will get saved inside this bronze folder right here. And I used f strings to define the path. if you don't know about f-strings used to create a dynamic string basically. Okay, when we just define the path, you can only define a static path, whereas when you use f-strings you can define dynamic path. The path can change according to the format that you define it with. So this whole part is still static. This whole part and this .json is still static. That don't change, but this path, this particular part, which is enclosed by flower brackets, will be dynamic. When I say that, what I mean is, so this timestamp, so the file basically saves with this name, flights underscore timestamp.json, but this timestamp will change according to this one, this variable. So it just changes according to the present time, the time that when the file is getting created. That's how we create separate files for every run. That is that, and then we define the path now. Then we do with open path, comma, w as f, and json dot dump of parenthesis open data, comma, f. What we're doing here is we're opening the path and then writing in the path. This is how you define it. So this is the format to define what you're doing there, the operation. What we're doing here is with open, we're opening the path, and the path is the path that we already defined, which is this variable right here. And comma, whatever you define here, whatever you put in here. Now I put in W, which stands for write. And if you put in R, you are reading from that path. Here I'm putting W because I have to write into that path because I'm creating a file and saving it in that particular path. So I'm writing into the path, so I use W. If you want to read, use R in the same place. And as f, json.dumps of, which means JSON has a lot of methods. We use JSON dumps, and there is JSON loads of. Here we converted the data into JSON file, right? Now we have to no, sorry. Yes, so JSON dumps of creates a Python format into JSON file. Here we have to save the file in JSON format, so we are converting it into JSON format before we save it. That's how we're doing it here. We have that. So with this, we are able to run it, and we can create it. This will create a JSON file for every run. It pulls the data out of the API and creates it. But at the end, we also have to define one more thing here. That is context of TI. Now we have to use square brackets here because we are referring to a list of context methods. Dot xcom underscore push of key equals bronze file value equals str of path. here, this particular line is so important to understand. Okay, here we're defining an XCOM push. What is an XCOM basically? If you already watched the masterclass, you will be already know about this topic, but I'm going to explain it again. Basically, I already said this to you, right? We are just defining a task first, and we'll be calling this task in the DAG to run. So any task in the DAG cannot communicate with each other. If there are two tasks in the DAG, it cannot pass a variable. We cannot pass a variable from task 1 to task 2 without us manually coding. That task cannot run, that task cannot pass it by itself. But by using XCOM, these tasks can communicate to each other. This is how it works. You have to use XCOM push from the sender, and you have to use XCOM pull at the receiver side to receive that particular returned object. Here, in this case, we're using context of semicolon. No, first we have to understand about this one. Okay, XCOM push. We use XCOM push to push the value out of this task, and the silver task will pull the value from that XCOM. It is like a communication broker basically. Here, key, we have to use this key as a unique identifier. So we use this key to pull this particular XCOM. We can identify this XCOM push through that key here, and the value is the actual object you are returning, which will be the path right here. So you're returning the path here. So what we're going to do in the silver is we're going to pull this using the key, which is bronze file, and we will get the path. Like I said, the path will change according to for every run, right, according to the timestamp. So that lets silver to retrieve the latest timestamped JSON file easily. That's how we are working it with here. And the context TI stands for task instance. So we use that .xcom push to push that particular returned object. Now we have the DAG file. We have we have the task Python file. Now we create, did I save it in scripts? Yeah. Now we have to create the DAG file. Let me close this .env, we don't need them. Docker compose. And let's create another file under DAGs. Now we are going to create the actual DAG file and name it. So we name it flight pipeline.py. Okay. We need to import sys module first. We're going to use it, then I'm going to talk about that sys module and the reason why I imported it. Then we need from add lib import path. And we already know why I import that. And then we also import datetime, just like we did in the last the task file. Datetime import datetime time delta from Airflow import DAG. We use that DAG module to define a DAG, or else if you don't use that, Airflow doesn't recognize that as a DAG file. So we need that to define it as a DAG. Then we import from airflow.operators.python import Python operators. We need that operator if you want to run Python in your DAG file. If your task needs it, by the way. If your task needs to run anything in Python, you import Python operator module. Say Airflow home path opt slash Airflow. This line and the next line are the requirements we have to define before we can able to pull any function out of this DAG file, because we have to import those Python, those tasks from a different file, right? Like I said, because our task is defined in another Python file, which is bronze ingest. In order to access them, we have to do these two lines, this line and the second line. Airflow home insert of 0 comma str of Airflow home. By doing that, we now can access the functions from the Python files out of the stack, and which are placed inside this repository, and nothing outside that. We just defined this repository, so we can access the functions in the Python files inside this repository. Now we import the bronze ingest, the function from the bronze ingest, not the total file. To do that, I'm going to use from scripts. We saved that .py file under scripts folder, so we use scripts dot bronze ingest, but we don't want the whole bronze ingest. We need the function inside it. So we say import, and the function name is run bronze ingestion. We copy that, paste it here, and like that we imported that function, and we define that function as task in this tag. So we have that. Now we have to define the attributes, the arguments for the tag first. So I'm going to create a dictionary first and then assign it to the tag. Default args, owner, Airflow, retries. So retries here, it is up to you. Whatever the value you define it here, it is up to you. So what this says is, if a task fails, how many retries do you need to do? Do you want the Airflow to perform? So I usually do one, but you can do any number here, but be careful. The more number of retries, the more time it takes to actually retry the executions. So here in this case, to make it faster, I'm going to go with 0 retries. You can, but it's up to you how many retries you define here. And then you define retry delay as well. And this is where we use the module time delta to define the time frame here. And we say minutes 5. So once any task fail in this tag, it waits for 5 minutes and retries again. And that's why I told you to be careful when you define the retries. So once it fails, it waits another 5 minutes. That's a lot of time to wait. Or else you can just take that out and say retries 0, and the time delays doesn't matter at all. Either way, that's fine. It is totally up to you. What else? Whatever you define there. And then we define the tag using the module that we imported, tag, and a parenthesis. First, start with the tag ID. And tag ID be flights, OPS, Medallion, pipeline. I think I forgot to explain what is Medallion. Medallion architecture, Medallion architecture is a way where you split the data transformations into 3 stages, which we used in this project. So we split the data transformations into 3 layers, right? Bronze, silver, and gold. That is what Medallion architecture is. Splitting the data transformation in 3 layers. We call it Medallion architecture. We have the tag ID, and then we assign the default args that we defined before. Default args, comma, start date. So we define the start date to say when to start this tag. You can define it in the past. I'm going to define it as the past. Today's date is 12/26. Today's 26th of December 2025. So I'm going to say 2025, comma, 12th, say 10. That should do. And schedule interval. Here we use cron format to define the schedule interval. We say for every 30 minutes, we talked about this in the masterclass too. The cron formatting, how to format these schedules. So this basically indicates 30 minutes. So this tag runs for every 30 minutes. You can define it as 5 here to make it run for every 5 minutes. And the next one, this one talks about hours, and this placeholder talks about days. So this one defines days. The first index defines minutes. The second one defines hours. Third one defines days. Fourth one defines months. Right? Yeah. And then this one defines the weekdays. Ranges from 0 to 6. we don't have that much of time to talk about all that, but yeah, that's the overview. Okay, and then we have catch up. We're going to define it as false. And then tags. We define tags to, you know, uh, search for the tag easily. Right now, we don't have any tags here because we created our custom Airflow container, so we don't have any DAGs here. But when we work for a company, there are a lot of DAGs, and if you want to search it, it is hard to search. But when you have tags, you can just search for the tag here, and any DAG that has that tag will be shown first. So it is a lot easier to search with the tags. That's why we create tags. But right now I don't need it because we don't have any. This is the first tag I'm going to create. So I'm not going to use that. We have that, and as tag, let's say bronze equals item operator of with parenthesis, then task ID equals bronze ingest. So we just define this task ID to display when we look at it on the UI. So this is the name that we can see on the task as the task ID in the UI. Python callable equals run bronze ingestion right here, comma, and that's it. We have this DAG ready to run. Let's go to UI, refresh. This is going to take a few seconds to pass the DAG. We have to wait. After it is passed, we can actually see the DAG. But right now we have to wait a few seconds. So let me pause this video and resume it after I see that DAG file here. And we got an error while passing the DAG. Well, this is our first error for this project, but might not be our last error. And right here, like I said, that's going to show you on top. And it also says what's wrong. Name error. Name path is not defined. Do you mean path? So if you go back to the code, right here, this is where I messed up. I used capital for everything. It's supposed to be capital P and ATH or lowercase. And that's it. Now let's say Control S to save it. Head back to the UI, refresh. That's it. Now we can see the DAG here. Now it is paused. To unpause it, you have to toggle this checkbox. You have to toggle the button here. It automatically runs the first DAG run. Okay, we got an error. Here in the graph, you can see which task failed. So these are first tasks. These are the only task that we have in this tag. So we click on it, switch to logs, click on the drop down right next to the post task execution logs. Here we can see the error. It says cannot access local variable path where it is not associated with a value. Okay, and it is pointing to this location. So let's head to the task now. So the error is with this line. And I can see the error. Remember I said capital P and the rest of the alphabets will be lowercase, but the first one should be capital P. This is how we define the path. Now save it, head back to the UI again, hit trigger. So that's how we trigger it. We click on the trigger button. Now it is triggered again. Now it is successful. Here you can see this, by the way, here you can see the success or failure of each task. The green indicates successful. Now it is successful, which means we should be able to see the data file saved under the data runs. There you go, the JSON file with the timestamp 2025, which is year 12, which is month 26, the date, minute, hour, minute, second. Let's open it. There you go. Right now, I think it is too long. Yeah, there you go. The whole thing. Yeah. Let's just close it. So the first task successfully created. Now let's head to the second task, which will be the silver layer, where we clean the data and create a JSON file again with the cleaned data. We pull the data from bronze first, the JSON file that we stored, we pull the data out of it, and then we clean it. For that, let's create another script. Under scripts, create another file, which will be named as silver transform .py. Silver transform.py. Perfect. We have that. First, let's import the modules that we need. Import JSON. We need JSON. Of course, we are working with a JSON file, so we need JSON. We need JSON module, and then we need pandas, because we, like I said, we are going to use Python for cleaning. We're going to use Python for cleaning. We're not going to use any external tool. Just to make it beginner friendly, we're going to use Python. The best way to handle the data, do the data wrangling, is by using Python and converting it into a data frame. That's why we are importing this module, pandas, to convert that into data frame and work on it. That's PD. Then we need the path again. Capital P, P-A-T-H. Now we define the function, which is the run silver transform of we push the arguments again, arguments as context of that task. Now I'm going to show you another method that we can use from the context of the task, which is execution date equals context of square brackets, like we used before, ds sh. Now we're pulling out the execution date of that task. Whenever the task runs, the context is different for every run, like I said, and that this particular thing pulls up the execution date and assigns it to the variable execution date. So bronze path equals capital EPAPH path of OPT slash airflow slash data slash bronze. Then we also define silver path. PATH. Just copy this thing, paste it here, and say silver. So just in case, let's add another line. These not mandatory, by the way. Just add silver path mkdir stands for make directory. So this just makes sure the parent directory is actually created, which is this one. We already created, but if you forget to create that folder, this will automatically create that before it saves the file. So you don't face any error. So this just makes sure if it exists or not. Now we load the latest bronze file. We only need the latest one. We don't want the old executions and the old bronze files that are saved, so we need the latest one. My bad. I just found out we don't have to write all this because I just realized we can just use xcomp pull to pull the file path, right? We don't have to define the bronze file path here. I'm not going to use that even for the latest file. What we can do here is we can just do xcomp pull to pull the path because we pushed it from this in this task, pushed it. So we can just pull it and use it. Say bronze file equals context of pi dot xcomp underscore pull. Ramps is open. The key equals bronze file. We identify the xcomp pull by bronze the ID, the key, and task ID equals, and the task ID is I think the task ID should be in the pipeline, which is this one, bronze ingest. From that task ID, that's how we pull it. Just to make the debugging easier, if there is no files, it has to raise an exception, right? Let's edit the exception too. So if not bronze, file. So if bronze file is empty, if not, basically says if bronze file is not empty, bronze file is nothing, then raise value error. The error be bronze file had not found in XCOM. That. We got the bronze path ready, right? And we have the silver path ready. And this line is to make sure the silver folder is created. If it's not created, this will create one. Then we go to bronze file SF equals JSON dot loads load of Remember when I talked about JSON.loads and JSON.dumps? Here we are using JSON.loadoff, which converts a JSON file into a dictionary. Here we opened using with open of bronze file, just like in the bronze ingest code where we use with open path. Here we used bronze path to open it, but instead of using W to write, here we left it blank, which by default takes R, which is read. So we are reading from that path and get this file and converted that JSON into a dictionary and assigned that dictionary to the variable raw. If df raw equals pd dot data frame raw, now if you remember the data we have here, you see this is a dictionary. The data is the JSON string is in dictionary. I mean the string is in dictionary format, and it has two values per what to say. I mean it has two keys, two type of keys. One is time, and the other one is states. That's it, right? And the rest are just inside the key, and the rest are the values. This whole thing is the value. Everything is value. So the key is just time and states. Now we don't want the time here, key time. We just want the states from this. That's why we said. That's why we use raw of states here. So we return the states. What we're doing here is from this loaded data, the dictionary, we're just selecting the states key, which has all the values that we need. We don't need the time key here. Just need that, and then converting it into data frame using pandas with this PD, and then assigning that data frame, the converted data frame, to df underscore raw variable. That is done, and next we have the data frame now, so we can do the data frame methods. We can use the data frame methods on the data. Okay. Here we define the column names in sequence because we just converted that dictionary into data frame, but still all this data doesn't have column names to it. Well, we converted this data into tables now using data frame method, the data frame model, but they still don't have column and column headings. I mean, they have columns, they don't have column headings. Now we're going to assign the column headers. For that, we just say df underscore raw.columns equals. Now we list all the column names line after line, and we can use these as column names. Comma. This is going to take a while to copy paste every one of the column names here. That's contact. Let's go to the next line. Arrow, altitude. We have home ground. Velocity. Then vertical rate. Sensors. This is going to take a while, but we're almost done. Geo altitude. Whatever that is. SPI. Then we have position, source, and category. That's it. We have all of that. Now we are assigning the columns to the data frame, but now this is a cleaning stage, right? So we're going to clean all the columns. We are going to select only the columns that we need and leave the rest behind. We don't need those. What are the columns that we said we need? We need the first one, which is a unique identifier, and then we have origin country, and then geo altitude, and then velocity. Let's get that. Now let's create another variable and assign the new data frame that we're going to pick to that variable. Square brackets and a square. The first column, which is this, and the second one, which will be origin country. I'll copy the whole thing with the codes. Then velocity, then geo altitude. That should do. Now we created a new data frame with only the columns that we need. But we don't have to clean anything else other than that, because that is already clean data. So we don't have to do any cleaning. That is great because I just wanted to make this tag beginner friendly and not too complex. So this is good. So output file. We define the path where to save the file. F strings. Use the execution date this time. Last time we used date time to get the UTC now, but now we're going to use this. Both are same, but I just wanted to show you the methods that we can use using the context. Then we have dot to CSV. It's converted it to CSV now. Before I said we're going to save it as JSON in Silver transformation too, but now change in plans. We're going to save it as CSV. Change the data to save the data frame as CSV. We use df.csv. df is the data frame variable name, and toCSV is the method we use to convert it to a CSV file, the data frame to CSV. Say output file, which is the path index equals false. So we say index equal to false to exclude the index value. When we create a data frame, it comes with the index by default. So we are going to ignore when we convert the data frame into CSV. We're going to ignore it by using index equals false. You don't need that extra the column. And lastly, we have to push that to the path through XComs, so we can pull it back in the goal transformation. So again, we do this context of EI dot push this time. To push that value, parenthesis open, find the key first, equals key silver file, the value be str output file. Now just print after everything happened, everything is done. We can use a print to debug it, but I don't think that is necessary. Which means this should be enough. This should be enough. We did push that XCOM through XCOM. Now we save it. Now we have to head back to the pipeline because we need to include that task in here. Right underneath the bronze one, we just have to create another for silver. Before that, we have to import that the definition, right? The function definition. So we have to do that again. Do this again for the silver. Scripts dot. This time it is silver transform. Silver transform. Import. And the function name is run silver transform. Let's copy paste it here. That's good. Now let's define it as a task. silver equals Python operator and an open parenthesis with the task ID equals silver transform Python equals run silver. There you go. Run silver transform. Now, because we have two tasks, we don't have to define it, but these two have to be run one after another. Silver and bronze cannot be run together parallelly, right? Because bronze has the value that pushes and silver has to pull the value that is pushed by bronze. So first bronze needs to be executed and then silver needs to be executed. And to avoid the collision between these executions, we can define the dependencies between the tasks so that it goes sequentially. And to define the path, we do bronze after silver. So now we are saying first execute bronze, and only after the bronze is executed, and that too with no errors, only then it needs to execute silver, or else silver cannot be executed unless bronze is successfully executed. Now save this, and I think that's pretty much it. We can just head back to the UI now, refresh it, switch to code, and make sure the new code is updated. It is updated. Switch to graph. You can see the two tasks. Before it was one task, now it is two tasks. So trigger this. Here you can see the first task and the second task. The first task is executing right now, and that is successful. Now the second task is failed, does have an error. Let's see the error. Path.mgetdir got an unexpected error. Argument. Okay. I think that is in the silver transform task. Okay. So it is not parent, it is plural. Parents. So it should be parents. Now save it. Head back to Airflow. Trigger it again. Now let's see what happens. The first one is executed as usual, but the second one again got an error. See what it is this time. This time it is length mismatch. Expected axis has 17 elements. New values have 18 elements. Okay. Let's take this thing out. Category. From the silver transform, let's take that thing out. So that is what it is talking about, the length. So I think I miscalculated it. I'm going to take the last one out. Now save this. Go back to Airflow, run it back again. Another error. Okay, so this is a spelling. I somewhere I spelled it wrong. I spelled the output file wrong. Right here, I can see it right here. Output. I'm so bad at spelling things. That's why I'm getting a lot of errors. But I apologize for all these errors, but yes, that's one of the errors I got. Okay, let's head back again, run it back again, trigger it. Hopefully it runs now. There you go. Now it is successful. Both the tasks are successful, which means that should be creating a CSV file in under the data, under the silver folder. There should be a new CSV file created, which is this one. You see that? So it has the column names on the top. So these are actually CSV file, but I don't have that Microsoft Excel to actually open it. So I'm going to show you here, right here. So these are CSV file. Okay, it has all the values. So we're done with the silver transform now. Heading to the next transform, which is the gold. We have to pull the data out of the silver table and then make it business ready and save it in bronze in the gold. Okay, let's head to that. Again, under scripts, create a new file. Name the file gold aggregate.py. Now I'm going to write this code a little bit faster than the other two because all the components I'm going to use in this code are almost the same. They're identical to the other two codes, so I don't have to explain them again. It's just waste of time. So I'm going to write that faster. I will still explain a little bit while I write that. That's it. I'm going to import pandas for the data frame methods. And then we have from app library include path. The same thing we used to define the path. And then we define the function as run gold underscore aggregate open parenthesis asterisk asterisk context as passing that as an argument, which we did with the previous task too. So now we're going to pull that XCOM silver path file. To do that, we create a variable and say context of ti task instance dot XCOM underscore pull of key equals silver file. I usually use double quotes for this. Okay, and task IDs equals which is silver transform. Perfect. Now we have the silver file path ready, which is pulled. df ed dot read ed dot read csv read underscore csv silver file. So we are reading the file now from the path defined we got from the XCOM pull. Now we do a small aggregation here. We do agg equals of df dot group by. We're going to group by the country. This be AGG. Okay. Total underscore flights. Going to create the new column with count of that unique height identifier. ABG velocity will be assigned with the average of the velocity. It will be mean on ground. Sum. Reset index of. Now I'm going to explain it. Okay. What we're doing here is we have multiple values. Okay, with multiple country. Did I spell country wrong? I did. Yes. We have multiple records for one single country in that CSV file. If you take a close look, we might find it in the CSV file too. CSV. So you see that you have multiple records for United States. See this one. If I just select this part, see all these bluish records are all United States. So we have multiple records for that, and which includes multiple flight departures, velocity. What we are going to do is we're going to group all those records with the same country name, which means we're going to create one single record for one country. We're going to group all of them, and the rest of the values will be aggregated. When you group everything, all the records to one record, country can be grouped just because all those records has one. Let me explain it clearly. Okay, so let's say we have these records right here, right? So they all have common value. When you group using country, we can just group everything into one, which is United States. But the rest of the records, what can be the rest of the records? We are not grouping them, right? So we have to group them too. When we group this, we have to convert those rest of the values to single values, so we can just create one row for all the records, right? I think you understand it. So just zoomed it too much. Okay, I'm trying to find an example. Just take this one. Okay, here for the second column, which is velocity, we have multiple values. So if when we group this, all of these values, we're not grouping them because all the values are different, but we have to convert them into one single value. We have 156, we have 145, we have 296. So we have multiple values, and we have 0. Okay, we have multiple values. We need to group all of them into one value, so we can just write United States, and the next row will be some value out of that. Can be just one single value, That's just an example, by the way, the value. And then the other two columns too, just one single value. Let's say 1,000. So it should combine together to one single record. We only need that, right? We can't just use all this data and dump it into a dashboard. It is not necessary. So in order to analyze it, in order to make this data business ready, we only need one record per country, so we can analyze it in the right way. That's why what we're doing here is we are aggregating these rest of the columns. See these rest of the columns, and using the aggregation method, there is sum which adds up all the columns and gives one single value, and there is average which takes a mean, which just takes the average of all the values, which also returns a single value. And there is, what else? There is low, there is high, there is max, min. And what we used here is, it's right here. So what we used here is we used count. So count will also, returns one value, right? And we used count for these IDs because we don't, any arithmetic operation but that ID will not make sense. We have to count the IDs, so we can have that count as the number of flights at that window for that country. So we're counting that IDs, and then we have velocity. We're taking mean of that velocity, and then we have on ground, the number of flights that are on ground. We're summing them up, which makes sense, right? We cannot add up velocity. That doesn't make sense. We need mean. We need average of velocity. We need the total number of flights on the ground. That's why we assign the appropriate aggregation method for all of them to return one single value when we group that with origin country. I think you understand it now. So that's how we did it. Now with that we make the data business ready. Next step will be gold path equals capital P PATH path and silver replace of this line. You don't need this line if you're not going to use the next process, which is the next task, which is ingesting this data into Snowflake where we create the dashboard. If you don't want to use any extra tool like Snowflake and you're just good with the CSV file and you want to connect Power BI or some sort of visualization tool to that CSV file, you can just need these lines. Wait, you also need, no, you need the next line. You don't need the context, this line, xcoms line, because this line is to push that path again, and then we write another task which ingests the data into a table inside Snowflake. So if you don't want to do that, you don't need this line. Xcom push key equals gold file the value will be str of gold path. That is it. We have that, and then heg dot underscore CSV. Now we are creating that output as a new CSV file, and the new CSV file will be goal path. And I'm going to talk about how we define that goal path. Now here, so we're going to create a new CSV file as index equals to false to ignore the index numbers, and then this is the path that the file gets stored. And when we define this goal path, we used path of silver file dot replace of silver comma gold. What we did here is we use the same silver file path, right? Use the same thing, which will be let's say over that way. Silver file. Yeah, there it is. This path. We use the same path, but what we did here is we replaced silver with gold. So instead of this, we just used gold. Instead of typing, again hard typing it, we can just replace silver with gold. That's it. And save the file in that particular path. I think we're done with the goal aggregation, our final task. Now let's connect it with the pipeline. So we're going to go from scripts dot gold, the gold aggregate, gold aggregate, import, and the function name is run gold aggregate. Copy, paste it here, save, and we have to define it then. Say gold equals Python operator, parenthesis open, task ID, which will be aggregate, goal aggregate, Python callable equals run gold aggregate. Yeah, run gold aggregate. That's it. Oh, I forgot. We also have to define the dependency. So this only executes after the silver is executed. Gold. Now it is complete. Head back to the UI again. Refresh. Now we can see the last task added, the third task, not the last one. Okay, now trigger this again. The first one's executed, the second one's executed. Now the gold aggregate. Of course, I'm gonna get an error. Click on that. Switch to logs. Columns on ground do not exist. Okay. So that is with this one on ground. So it does not exist. Okay, that makes sense. So I used altitude here instead of on ground. Oh, that was my mistake. We also have the silver. We also have to change the silver transform now. We don't need the altitude here. What we need instead is on ground. So instead of geo altitude, we need on ground. Same with this one. So we don't have to change that because we already got that. Okay, so you have to change that in silver. Or if you find any other columns interesting, you can use those columns too within these things. Let's head back to the UI. We run that. Now this should work. There you go. Which means if we head back under the gold, there you go. The new CSV file is created with origin country, total flights, average velocity on ground. And because we grouped it to make that data business ready, there is only one record for every country. So if I select that, you won't see any other blue marks, which shows the duplicates. So there are no duplicates. I mean, no, we don't have multiple records for one country name. Okay, so for now, we're done with the third process of data transformation too, and we have the CSV file right here. So if you don't want to import the data into Snowflake and do these data visualization, creating a dashboard, you can just use that CSV file to connect to Power BI or any visualization tool, this cold CSV file, and create a dashboard right there. Or if you want to do that Snowflake process too, you can still stay. Now let's head to the last. No, not the last one. We also have to create dashboard. We might not create the whole dashboard. I'm going to show you how we can create a few charts, and you can create your own dashboard from the data that you have. If you think the data is not enough, you can just add a few more columns in this silver and the gold here, update them and use them too. That's fine. Okay, the next task will be ingesting this data into Snowflake. Let's create that. Go to scripts, new script, name the script as load go to Snowflake. This is going to be a quite lengthy process here now, but let's do it. First, the basic imports that we need to work on the data frame, which is pandas. That's PD. And then import. We need Snowflake connector because we're connecting Snowflake. We need Snowflake connector. Then from Airflow dot hooks dot base import base hook. If you watch that masterclass, you would know that what these hooks are. Hooks are nothing but connections to external services without exposing those credentials in the hard-coded, without hard-coding the credentials in the code. So we can use hook to connect to the external service. I'm going to show you how that works too. Then we define the function first. Load gold Snowflake, and the arguments context, we pull the gold file path, which is context of ti dot xcom pull underscore pull, and then open parenthesis key, I think it's gold file, gold underscore task ID equals gold aggregate. That's it. If not gold file, raise an error, raise value error. These is not mandatory, these 2 lines. These just for, make debugging easier for us if something goes wrong. If there are no files in the server, this error will raise. XCOM. So if there are no file paths defined in XCOM, it says gold file not found in XCOM. And then we get the execution date from context, just like before, but using date, data interval start. So context also have these things. It has data interval start, data interval end. Now what does that mean? You remember in our case, I'm going to take an example of our case to explain. Right? In our case, we schedule the DAG to run for every 30 minutes, right? Now what the context takes is, let's say our DAG run, when the DAG run, this task will also run, right? So it passes the context arguments, which has all these data in it. The data interval start ti, which we used here, and data interval end. It has all of it. Now let's say, let's take a run first. So the DAG run happened, let's say the DAG run happened at 8:30. Now when the DAG run happened at that time, that means this DAG run is responsible for this time window, which is 8 to 8:30. All the data that is generated between this time window is responsible for this 8:30 DAG run. You get it, right? Because our DAG runs for every 30 minutes. If our DAG runs for every hour, then that's quite different. Then this is responsible for 7:30 to 8:30 data, because the previous run will be at 7:30. So anything after that will be responsible to lost it. Anything that happens after that is responsible for the next DAG run, which is 8:30. So when we import the context and when we say DAG interval start, the DAG start interval will be 7:30 and not 8:30. For the DAG run, for the 8:30 DAG run, the data interval start will be 7:30 and the end will be 8:30. This will be the start, this will be the end. That's how it works. So we're assigning that to the execution date. Now string format time of percentage y hyphen percentage m percentage d hyphen percentage h. So just formatting that timestamp by a year, month, date, hour, minute, second. Perfect. Then df equals td dot read underscore csv of action equals base hook. Now we are connecting to Snowflake. Base hook dot get connection of flight underscore Snowflake sf cyn connection equals. So what we're doing here is we have to create this connection, but we haven't created that yet. We have to create that in Airflow. Then we are hooking it using get connection base hook. Let's create that connection first before we go further. Let's also open my Snowflake. By the way, Snowflake offers a free trial for everyone who logins, who signs up for the first time. So it offers 30-day free trial with $400 worth of free credit, which we can use in this free trial period. You just log in. You don't need any card or payment details to be entered. You can just log in with a. You just need, all you need is email ID. That's it. So this is the home page. In Airflow, head to admin connections, new connection ID, which we already defined here as flight Snowflake to be connection ID, and connection type should be Snowflake. Search for Snowflake. There you go. Schema. We have to create a database and a schema and a table in Snowflake. Let's create a new SQL notebook, SQL file. Let's say create database, and the database name be flights. Select it, run it. That is created, and then create schema. Name the schema as KPI maybe. Create this schema inside the database, our database that we created. Now let's create the table. Create it faster, create table, if not exist. Say, don't need the if not exist. Say, flight APIs. The columns. Start. Timestamp. We still haven't reached the Windows Start part yet, but it's going to be country, text, total flights, which is integer, g velocity, float on ground, and we do load time as timestamp default as current timestamp. Choose Windows Start. And origin country. Okay, let's run that. Okay, the table is created now. Here, what we're going to do next is we're going to combine all the records for the Windows Start, which will be 30 minutes span, which we will combine the whole data into one record and then store the Windows Start in this column. The origin country, total flights, average velocity on ground, and the load time will be the current timestamp by default. The primary keys are Windows Start and origin country. That's how we created a table now. Make sure it is created, head to catalog, refresh this. Oh, there it is. Flights database, which we created. These two are the default schemas, ignore them. This is the schema that we created, KPI. Under KPI, under tables, we can see the flights KPIs table created. Right now, there is no data in this table. We are going to ingest data into it. Now let's fill in the details here. Now, schema, which is KPI, and login, your username here, the Snowflake username, and the password here. And the account name will be this one, session details. Click on copy to keyboard and open a new tab here, paste it. Select only this part of the Snowflake context, only this part. Everything after the double slash and everything before the .snowflakecomputing.com. Paste it here, the account. And for the warehouse, that will be compute warehouse by default, but just make sure that is the one. Head to compute here in the Snowflake and see which is active and in which you created it. So basically it should be compute WH when you first create it. Say compute WH. Do that in capitals just in case. Compute WH, and then database, which is flights. Is that flights? Flights. Flights. We don't need to put in region, but we need the role. Is account admin, and that's it. Account admin. Okay, now let's save this. Head back to here. Now this makes sense, right? We just hook that connection that we just created to this variable. Now we are going to connect to it, like actually connect to it. Password. It's connection dot password. So we are pulling this information from the connection that we created. Then we need account equals connection dot extra de JSON. Get JSON. Account warehouse equals connection dot extra underscore d join d JSON dot get of warehouse the database So you might wonder, for a few of those configurations, we just said connection.login, connection.password, but for the other list, we use connection.extra.djoin. I don't know the exact reason, but on online, that is how they say that is how we have to connect, Snowflake using Python, using the Snowflake connector. That's how we have to connect to it somehow. No, sorry. I mean the Airflow connection, when we use the details from it, that's how we need to, match them. I'm not sure about the exact reason, but that's how we do it. Schema. And we don't have to, remember these syntaxes because they change for every update. So we have to check online, or we can ask AI to write that for us, the updated ones. Okay, I think I'm done finally with the configuration. Now I'm going to write an SQL where I merge the data with the table. And I used merge instead of insert because whenever the new data gets inserted into get added to the table, if we use insert, it creates a new record by default. But if we use merge, if there are the same type of records in the table, they just get merged and the rest of the columns get added or aggregated. So I'm going to use merge to avoid the duplicates. I'm going to write the merge SQL. You know what? I'm hungry. I think I just have to copy paste the SQL code, the whole SQL code from one of my files, and I'll just explain what I just did in that because I'm just exhausted. I cannot write any of this anymore. I've been talking continuously, so I'm just exhausted. So I'm going to copy paste that. Should be in script. This one. I'm just going to copy the paste the whole code. Screw it. There you go. So now I'm going to explain what I did here. We are defining a query which we use to merge into flights KPI target, which is our table that we created in Snowflake. Remember, flight KPIs, and then we aliased it using TGT to represent target table. That is the target table where the data has to go. And then we created a select, which acts like a temporary table inside this query. And we used placeholders here. We haven't assigned any data to that columns, we just used placeholders. For now, when we created this column using select, and we merged these two, the temporary table and the target table, and on we use target.windowStart. So it takes that as an attribute and origin country as an attribute. So if any common rows are in the target table that are coming from the source table, in these two columns, only the window start and origin country, if there are any duplicates, they just get merged. So that's how the next line goes. When matched, then updates it. So when these two tables match, these two table columns, which are window start and origin country matches, then total flights equals source total flights, and average velocity equals source average velocity. Update that with the source and not the target. So the target values will be updated with the source. And when not matched, then insert. So if it is not matched, then insert, which insert these columns with the values as source window start, source origin country, source total flights. That's how this query works. And we just write this query and assign the query to this variable for now. Then we used with sf connection.cursor. We use this one, the sf connection, which connected to the Snowflake by using Snowflake connector.connect. And Snowflake sf connect.cursor creates a new cursor. You're asking Snowflake to create a cursor so you can write queries, you can run queries. So it creates a cursor and asks cursor for underscore dot row in data frame dot iter rows. So we are iterating through the whole data frame that we are working with. So we're iterating for every row throughout the whole data frame. So these are we iterate the data frame, and when we iterate, it generates an index and a row. And we don't want the index, right? So we assign it to underscore and we ignore it totally. We don't want the index number, we just want the row value. So we're going to assign the row value to row, and then cursor execute, merge SQL. For one row, it uses merge SQL, which is this one. And then these placeholders that we defined in this query using %s will be replaced with these values that we are passing here, which is a row of origin country, int of total flights, float of average velocity, int of on ground. These will be replaced with those placeholders, and then they are compared and merged, inserted if they are not matched, or updated if they are matched. That's how it works. Okay, I think we're done with it. There is no way I'm going to write all the code by myself right now. I'm so exhausted. That's why I just copy pasted it. So anyway, these are the last code, but still I explained it, and I saved it. Now let's update the pipeline again. It will be from load goal to Snowflake, import the function which is named load goal to Snowflake, and then at the end here load to equals Python operator, parenthesis open, ask ID will be load gold to Snowflake, comma, Python callable equals load gold to Snowflake. That's it. And here at the end, just call this. So that will be our last task, to load the data to Snowflake. That if this executes, we're done with the Airflow stuff, and then I'll show you how to create the dashboard. You can do that by yourself. Let's head to the UI again. Refresh to the DAX. We got an error. The error is no module name load gold to Snowflake. Okay. Interesting. No module name load gold to Snowflake. There should be really here. I forgot to add scripts at the beginning. Scripts load gold to Snowflake. That's how it should be. Retry. There you go. Okay, now let's trigger this again. Hopefully it works for the first time. It never happened to me, but we'll see. There you go, our last task, error. Okay, let's find the error and fix it. Logs, and the error is strftime not. Did I miss something? Did I misspelled it? It's ironic. I used a comma here instead of dot between those two, the context and the string format. Now I replace the comma with the dot. Let's try to attempt it again. I think I can just run one single task, just the task that failed. I'm not sure. I think I forgot how to run that, but yeah, I'll run the whole tag, that's fine. Okay, again. I think it's a different error this time. Execution TS is not defined. Okay. Where's execution TS? Supposed to be execution time now. Okay, this one execution TS. So it should be execution date. Oh, because I just copy pasted it, I got this error. So it should be execution date. Now this should work. Run that again. Says the timestamp is not recognized because there should not be a hyphen between the date and the time. Where right here. So there should not be a hyphen. There should be a space between the date and the time. Save this. Run that again. Zoom out. It's taking a while. I think it is ingesting the data into the table. There it is. Yeah, it is ingesting the data. It is processing. It already ingested 63 records. It's still going. I think there are like 101 records or something. So right now we have 63. Refresh it. 82. Still going. 95. It's almost done. 102. Yeah, I think 102 is the one. There you go. Now it is successful. By the way, all the codes that I just wrote here will be given to you in the GitHub link down below in the description. You don't have to write them manually. By the way, if you want to write them manually with me while I explain it, you can do that too. But you still have the links. You can just directly download them and run them on your PC. Okay, we're done with that. Now, our next step. So if we go to the architecture, we're done with all these 3 data transformations. We already inserted the data into Snowflake. Now we have to create the dashboard inside the Snowflake. To create a dashboard in Snowflake, click on the plus icon, click on dashboard here. Before that, I have to talk about the data. The worksheet that we created. Let me zoom in so you can see clearly. Okay, that should do. We run from flight KPIs. Okay. So if we select one country, Kenya, let's say Kenya, where origin country equals India, that should be capital K. So it only prints what's that? origin country equals Kenya. My bad, we cannot use double quotes here. We have to use single quotes. Now let's run that. We only have one record for every country, but if we run this, if we let the Airflow, the DAG run for the next half an hour, a new record will be added because we are windowing it for every half an hour, and this half an hour is at 8:30. So if we wait another half an hour, a new record gets added at 9. And for every half an hour, a new record gets added for that particular country. But for now, we only have one. But if we wait half an hour and run it, we'll get an extra. You don't have to run it, by the way. We already scheduled it, so we just have to wait half an hour to let the Airflow run the DAG again. Then you will get another country here. Not other country, another record for the same country. Okay, now let's create the dashboard. Click on the plus icon, click on dashboard, dashboard name, let's say flights activity, flight activity, that's fine. Create dashboard. Here, new MySQL worksheet. You select the database and the schema. Okay, and here you select the columns that we are using for that dashboard, the chart. And we are creating one single chart. And I want to see the columns that we can use here. You can create a line chart for time and any attribute here, but we cannot create it right now because we will have one record for every country, remember? Yeah, if we wait multiple half an hours, or let's say multiple, if we let the DAG create multiple records for that particular windows, then we can actually create a line chart for that time to the total flights chart, maybe something like that. But we cannot create the time chart now because we only have one record for every country. We only have one time frame basically. So let's create a different one. Thinking. Say, select origin country and total on ground flights in that country. Run. Flights KPI table. Well, this is just an example, but if you want to actually see or learn more about Snowflake, I already done a masterclass in Snowflake about Snowflake. You can just go check it out. In which I already show all the techniques that we can use in Snowflake and everything about it, and also creation of dashboard creation. So, okay, now let's run that. We will probably have multiple values. Does not exist. Why? Oh, it is flight KPIs. Okay, now run it. A lot of values, so see that? But we cannot use this chart, right? There are so many values, we have to limit them. So we can limit them by using limit. It's just this. limit to 5. I'm not sure about the syntax here. If I'm doing it right or not. Let's run that. There you go. Oh, I have to order it first. I have to first order by descending, right? So now we're ordering the countries in descending order. To define the order by on ground. Okay, now let's run it. There you go. So we have the top countries that have on ground flights. We can also change the type of chart by selecting here line, bar, heat. We have scatter, heat grid, scorecard. Scorecard is like a KPI. I'm gonna create another one with the scorecard just to show you. And yes, that's it. Like that, we created a chart in the dashboard. Let's add another one. This worksheet. Same database schema. This time, let's say select count of now sum of on ground. So I'm going to take photo of planes or on the ground from flight KPIs table. Now I'm going to create a scorecard here, just like a KPI card in Tableau and Dashboard. Tableau or BI. Show scorecard here, and just like that, we have a scorecard. So these are like the KPI matrices, key performance indexes, and these are the charts that we use bar chart here. And that's how we create a whole dashboard in Snowflake. And yes, with that, you can just play around with this dashboard. I think I'm done with this. Okay, now we have the architecture. Let's have an overview of what we did. We pulled out the data from an API, and then we stored it in the bronze layer as a JSON file, and then we pulled out the data from the JSON file, which is the bronze layer, and then cleaned it, and then stored as a CSV file in silver layer. And then we pull the data from that CSV file again and make that data business ready by just excluding a few columns and aggregating them, and then stored in the goal layer. After that, we ingested that goal layer data into Snowflake table by creating a table in Snowflake. Then from that table, we created a dashboard in Snowflake. That's the end of the project. Yeah, that is it. So again, link for every single file and every single code that we used in this project will be given to you down below in the description. The codes and all the files basically will be available in the GitHub link, and these Open Sky Network links will be given directly in the description itself. You can just go grab them, and that's it. If you like the video, don't forget to subscribe and share to your friends who actually are interested in the project like this. Okay, with that being said, adios.